now we'll move on to the Bayes theorem problem, problem 6 and 7. And remember, you do not need to memorize Bayes' theorem. You will get Bayes' theorem in this form right here when you do the test on the problem on the test. Probability of H given E equals the probability of H times the probability of E given H over that same number plus the probability of not H times the probability of E given not H. So to solve this problem, what you're going to want to do is going to figure out what is the hypothesis, what is the evidence, get all the basic probabilities out of the statement of the problem, and then apply Bayes' theorem. Okay, so Marisa, why don't you read us the situation?
Okay. Alfred and some of his British buddies are member of a weekend competitive cycling team, the Cyclamates. Over the past 5 years of competitions, Alfred has turned in the fastest time on the team in 20% of their competitions, 0.2 or 1 in 5. However, the Cyclamates have only won the team championship in 5%, 0.05 or 1 in 20 of those races when Albert turned in the team's fastest time. They've won the team competition 25% of the time when another teammate turns in the team's fastest time.
Okay, before we go, let's just make sure everybody's clear on the situation. Okay, so you've got this team, the Cyclamates, that is a competitive cycling team. One of their cyclists, Alfred, is a person who has won the individual competition in these weekend matches. He wins it basically 1 out of every 5 times they race. The Cyclamates, however, only win the team competition 1 out of every 20 times when Alfred is the individual champion, and the Cyclamates win the team competition 1/4 of the time, 25% of the time, when one of the other team members is the winner is the individual winner. Okay, so that's the basic setup. Now what do we ask about?
Okay. This past Sunday evening at their favorite pub, you saw Alfred and all the Cyclamates celebrating another victory. 6.
Team victory.
Right. What is the new posterior probability that Alfred turned in the team's fastest time at this weekend's race?
Okay, so the hypothesis here is that Alfred turned in fastest time. And the evidence here is that the Cyclamates won team competition. Okay? So this is the hypothesis, because this is what you're being asked to update, the probability of this in light of the fact that the Cyclamates indeed won the team competition. Okay? So now what we need to do is get all of our basic components of Bayes' theorem, and then we just plug them into and do the math. Okay? So one thing we're going to need is the prior probability of the hypothesis. The prior probability that Alfred turned in the fastest time. Well, remember, in the statement of the problem, we were told that that happens 20% of the time. So what then is the probability of not Alfred turning in based on prior performances? 0.8. The probability next we need is the evidence of the probability of the evidence given the hypothesis. What is the likelihood that the Cyclamates won the team competition assuming that Alfred turned in the fastest time? And we've been told that that probability is 0.05. And finally, we need the probability of the evidence given the negation of the hypothesis. What is the probability that the Cyclamates turned in the fastest time if Alfred won the team competition, if Alfred did not turn in the fastest time of the team? We were told that that was 0.25. And so we've now got all the components we need to apply Bayes' theorem. We can now calculate the posterior probability of the hypothesis that Alfred turned in the fastest time at this last weekend's race based on the evidence that the Cyclamates won the team competition by just plugging these numbers into Bayes' theorem. So that's going to equal the prior probability of the hypothesis, 0.2, times the probability of the evidence, the likelihood of the evidence given the hypothesis, 0.05, over that same number, plus the probability of the negation of the hypothesis, 0.25, times the likelihood of the, 0.8, times the likelihood of the evidence, given the negation of the hypothesis, 0.25. And so now when we do our math, we're going to get